Hello guys, my name is Ivana Tilca. I'm Quality Manager at 3XM Group and I'm a Microsoft MVP for Artificial Intelligence. Today I have the pleasure of sharing with you some of the new and awesome things going on with speech recognition and mixed reality. Please always feel free to connect with me through LinkedIn, Twitter, or my blog. I will be happy to answer any question you may have or just share with you. So for those of you who are new, thank you so much for joining me in this tutorial. So some of the first thing I want to do is make sure that you guys are familiar with all the topics we are going to be covering. So today we are going to cover Cognitive Service Speech Sdk, which is a client library that allows developers to put features into their apps, either interactive applications, offline applications. Okay, so with Cognitive Services Library, both the older and the newer, you can do a bunch of things that we are going to see in this demo. High level, you can do interactive recognition, you can feed things from a WAV file, you can get the text back out, you can translate. Basically, this tutorial is for taking advantage of voice recognition. A key feature which is now in every major mobile operating system. We need to start thinking hands-free as a superior form of text interaction. You know, now with COVID, everyone is trying not to touch things. Well, I think this is the key. Okay, let's begin.
Now, it's a pleasure to be here in Las Vegas to present to you. It isn't always easy for me to travel across the world. And even when I do, I can't always speak the local language. Well, what if neither language nor distance mattered for me to deliver a fantastic keynote? What if technology could help me be anywhere I needed to be and speak any language I wanted? Well, it can. We are bringing together the power of mixed reality and Azure AI services to create a truly game-changing experience. First, let me introduce you to Mini-Me. There she is, my perfect holograph. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote, so let's get her up so she can do full-size Japanese keynote. Render keynote.
Hologram になることには本当に驚くべきことがあります。私たちは最新の複合現実キャプチャ技術を使用し
To do this, we use mixed reality technology to create my hologram and render it here live. Then we use Azure speech-to-text capability and English transcription to get my speech. Then use Azure Translate to get the speech into Japanese. And finally, applied neural text-to-speech technology so it sounded exactly like me, just speaking Japanese. And the most amazing part? All of these technologies exist today.
In July last year, Julia White presented this scenario in a keynote at the Microsoft Inspire Partner Conference. It explains exactly the power of Mixed Reality Toolkit plus artificial intelligence. Let's understand what Julia explained during that keynote. So she mentioned that her hologram was rendered in real time speaking Japanese with her own voice. How did they build it? They used mixed reality technology to create the hologram and render it. They used Azure speech-to-text capability in English transcription to get her speech. Then they used Azure Translate to get her speech in Japanese, and finally applied neural text-to-speech technology so it sounded exactly like her. I am pretty sure you guys are thinking this is too far away from us at the moment. Well, this session will cover each one of the technologies Julia mentioned to show everyone in high level that we can now already build a hologram like that. Hola, soy Ivana, estoy transmitiendo mi holograma desde Azure Kinect. ¿Nacho?
Hola, Iván.
So for anyone that does not know what Azure Connect is a developer kit with advanced AI sensors for building computer vision and speech models. It combines an advanced depth sensor and spatial microphone array with a video camera and orientation sensor. So I render my hologram with Azure Connect. I only have one sensor. If I had more, I could render a 360 degrees hologram. Other important item to mention regarding user mixed reality toolkit is the fact that we will be working for different platforms, not only HoloLens 2 but also iOS and Android. You can see tutorials about working with holograms and Azure in my blog. For our agenda today, I'm going to cover the speech recognition SDK. We are going to do a really small demo, which is one of the console demo that you can see everywhere, for you to understand how the speech recognition service works. Then we are going to get deeper into mixed reality, and we are going to implement speech recognition inside mixed reality. So we're going to be consuming the cognitive services from our HoloLens application in this case. Then I'm going to end our session with some of the things that I think that Microsoft is pointing out for the future. So hope you guys enjoy this session. We are going to be using pre-built AI services to add human-like capabilities to applications. But what does that really mean? It means things like giving the apps the power of vision and the ability to see and to understand the images. It also means things like giving your application the ability to speak and to understand spoken voice. And it also means the ability to understand information in general, to be able to process a large collection of files or documents or data, and then use human-like intelligence to extract knowledge like the topics being referenced or detect unusual patterns in the data. So there are a lot of things you might want to do when it comes to enhancing applications. Of course, we are talking about human-like capabilities, so let me give you a few examples. You could give your app the power of speech, say by adding a chat interface. You could give your app the ability to see and to understand the content of images. You could also give your app the intuition to understand what your users are most likely to want to do and optimize your user interface automatically. You could give your app the power of comprehension and communicate with your users whatever their spoken language is. And you could automate the human process of scanning streams or data from anomalies and react accordingly. These are just a few examples. Azure Cognitive Services include more than 24 APIs, but at the broadest level, they offer capabilities within these categories of human capability. In this session, we will cover the Dotnet Speech Sdk. This SDK lets your app perform speech recognition with input from a microphone. The Dotnet Speech Sdk is a .NET Standard 2.0 library. In other words, it's cross-platform. It can be used on .NET Core, .NET Framework, Mono, Universal Windows Platform, Unity, and even iOS, Mac, and Android. So Cognitive Services Speech is broken into 4 different sections. The first section is speech to text, which we will cover again through this course. Next is text to speech, which allows you to build apps and services that speak to users naturally, improving accessibility and usability. Convert text to audio in real time, play it back, or save it for later. By applying the latest in digital speaking innovation, the neural text-to-speech capability makes the voice of your apps nearly indistinguishable from recordings of people's. You can use neural text-to-speech to make interaction with chatbots and virtual assistants more natural and engaging. It can also convert digital text such as ebooks into audiobooks, and you can also use it to enhance in-car navigation systems as one of many examples. Speech recognition or speaker verification allows you to use your voice or any voice for verification. The API can be used to power application with an intelligent verification tool. If the speaker claims to be of a certain identity, use voice to verify this claim. And last but not least, Speech translation. The Speech Translator API is a cloud-based automatic translation service, which enables developers to add end-to-end real-time speech translation to their application or services. For the speech-to-text services, as previously stated, you can transcribe a short, less than 50-second speech segment with either the SDK or the REST API. With the SDK, you can transcribe longer utterances, longer than 15 seconds, and transcribe streaming audio. The SDK allows for the integration with language understanding intelligence services, also called LUIS, so that intent and entity can be derived from the audio being sent. Okay, so let's create our speech service. Go to portal.azure.com and log in with your Microsoft account. Under All Services, select the AI plus Machine Learning and Cognitive Services. Under Cognitive Services, select the option Add, and you can then search for speech, and you can then select the first one. Let's create it. Okay, so now we are going to give a name to our service. We are going to attach it to a subscription. We are going to select a location, and then we are going to select as price tier one of the two options. F0 is the free tier, but we are going to use S0 just because it's faster and we don't have a limit. And then you can create a resource group for your demo. Once you filled all the fields, select create and wait until your service is created. Once everything is done, you will be redirected to the cognitive service speech service. If you move to keys and endpoint, you will have the keys you are going to be using in our test. Okay, so next let's open up a Visual Studio 2019 in my case, and I'm going to create a new console.NET Core application. Once we have assigned a name and a location, we will create the project. Okay, so we have our solution with the files that we need. Let's add our Nugget package. So we'll go to manage Nugget packages and we're going to search for the speech package. Once we have it, let's install it. Okay, we have it installed already. We are going to reference not only the Nugget package, but some of the things that we're going to be needing in our code. So what I'm going to create now is a function. Let's go here and add it. So basically this function starts by instantiating a speech configuration object. This configuration object is required to create the speech recognizer object. We also are calling the recognize once async. This will start speech recognition and it only returns after a single utterance is recognized. So basically the end of a single utterance is determined by listening for silence at the end. The end of a single utterance is determined by listening for silence at the end, or until a maximum of 15 seconds of audio processed. Once the result is ready, we'll get the speech recognition text. The next thing we're going to do is replace our main code in which we are going to call our function. Once everything is done, let's run this. This is a test. Awesome. So it recognizes what we are trying to say. Okay, it's important to understand that in this situation we are only recognizing a pretty short utterance taken from our microphone. We can also recognize speech from an audio file and from stored in blob storage. There is a lot of documentation, docs.microsoft.com, and you will see a lot of code that can help you build different type of recognition. In this case, we are only demoing this because the idea is to understand how this is implemented in mixed reality. Okay, so let's see how our cognitive service can translate. So for that, I'm going to first of all reference our translation service, and I'm going to create another function that actually manages the translation. So in here we are going to have target languages. Basically we are going to speak in English and translate to German and to French. I will replace my subscription key and my region, and let's test. Okay, we're ready. Hello world. Great, so we have it in 2 languages. What if we want to add more languages? How do we know which one are the ones that are available from our cognitive services? If you go to the documentation that Microsoft has available for the speech service under language support, you can see all the list of languages that are supported. Right now we are going to add as a target language to Spanish, so we can see that what would be the translation in Spanish of what we are saying. So let's test this out. I am having fun. Okay, great. So there we have. Okay, so let's talk now about the Mixed Reality Toolkit and how we can implement the speech services into an application in our mixed reality. So the Mixed Reality Toolkit is an open source kit that Microsoft is developing, already available in the version 2.3.0. Basically, they are components and building blocks for common special interactions and user interface. The toolkit provides us with tools so that mixed reality experiences can be developed quickly. So what do I need to start developing for mixed reality? If you are using universal Windows platform, basically Windows Mixed Reality or HoloLens 1 or HoloLens 2, then you need to install the Windows SDK. Of course, you also need to install Unity. Right now I will be working with version 2019. You need also Visual Studio 2019, and it's optional to install the emulators for mobile or even for HoloLens. Okay, so the mixed reality team wanted to create a cross-platform solution with predefined performance that ensures that every time you run your project, you get the same level of performance you need from each solution. This version of Mixed Reality Toolkit is compatible with different platforms, as you can see, with iOS, for Mac and Android. Let's talk a little about packages. So Unity works with already pre-built packages to import different assets, what they call, which is already built 3D models, for example, or libraries or whatever they want to reuse from another project or functionality available in the market. So the toolkit by itself is divided into different packages. There is one that is the main one. We call it the foundation package, which includes the main components necessary to create the mixed reality application. Then we have optional packages like the extensions that include additional services that basically it extends the functionality of the kit, such as physical support, smooth scenes transitions, among others. The tool packages also includes useful tools that enhance the development experience. And we also have the example package that brings demonstration projects that illustrates the characteristics of the kit. In case you are developing for mobile devices, you should also include the augmented reality unit pack. The add support for devices, we will also incorporate the R Foundation package as well as the R Core or R Kit packages. It depends, of course, in the platform you want to export your project. So before the version 2017, Unity has been using a .NET 3.5 equivalent scripting runtime. With the release of 2018, Unity is projecting to make the upgraded scripting runtime the default selection and to update even further to C#7. So .NET 4.x provides access to the latest .NET 4 API. It includes all of the code available in the .NET Framework class library and supports .NET Framework 2.0 profiles as well. So .NET 4.x provides access to the latest .NET 4 APIs. It includes all of the code available in the .NET Framework class and supports .NET Standard 2.0 profiles as well. So what does this mean? Okay, so I'm going to create a new project to show you how to import the Nugget packages. Okay, so I have my project in here. I'm going to asset custom package. I'm going to insert on my desktop the Nugget for Unity package. Let's import it. Now I have Nugget under my menu. So if I click on Manage Nugget Packages, I can see the list of Nugget packages in here. Let's say I want to search the cognitive package. Check this out. I can install already my speech Nugget package the same way we did it on our Visual Studio application. This is one of the ways you can start working with this. Okay, as I just showed, you can import our Cognitive Services Speech Nugget package, but if we don't want to install Nugget, then we can just import the Cognitive Services Speech package. Now, as I always mention, we are working with just released technology. The only package that right now is available to install is the speech service. We still have to wait for the other services to come out. And if you're wondering what's the difference between this already built package and adding my library, is this one. Okay, so if I go to Asset and directly I can import my Cognitive Services Speech package. What is the difference between adding the manual DLLs versus this one? This is the main difference. In here you have all the necessary libraries for it to run, not only as you can see on Android, by iOS and other platforms. Okay, great. So now let's try to have our demo in mixed reality. I have in here a Unity project in which I already imported the Mixed Reality Toolkit Foundation 2.3.0. The other thing I imported is the Speech SDK that I just showed you. And then I have some other items that I'm going to explain right now. So I'm going to create a new scene, so I have everything empty. And then I have already built a prefab that we are going to import to our scene and to do all the magic. But let's first prepare our project. So I'm going to Mixed Reality and I'm going to add a scene. As you guys know, we have different profiles that are imported with our package. So we are going to work with the HoloLens 2 configuration profile because it's the one that most fits and most adapts into our scenario. Since we are going to be at some point exporting this application to iOS and Android, then we need to select the HoloLens 2 configuration package. What we are going to need is to edit some of the configurations that are already set for HoloLens 2. One of those configurations is the microphone. Why? Because any applications developed with this profile enables the microphones to be used when the application starts. So basically the development that you are going to be building is listening to the microphone the entire time. But that's not the scenario that we are going to try to build. We need to say which one is the sentence that we are going to be translating and when it's going to start and when it's going to end. That's why we need to clone our profile and we are going to the input area. In the input area, we have different configurations, but as you can see, speech, I cannot edit this. That's why I need also to clone the configuration profile for the input, and I need to clone the one from speech. Once we do this, we can select the manual start configuration. So we are going to tell our application that start listening or has access to our microphones once we click on a button that we are going to say, okay, start listening to me. Let's move this out and let's drag and drop our panel. So now we have in our scenario our panel. What do we have in here? We have different game objects. We have a background, a connection light that is going to tell when we are already connected to the service or not. And we have our output text. What our application is going to listen to us once we click on our microphone, is going to send the audio to the service, to speech service, and that's going to translate to text what we are going to see. So let's try to code this. What are we going to do? So I have some scripts in here that are going to do all the magic for us. I'm going to drag and drop and assign it to our panel the script called controller. As you can see, I already have some fields that script is waiting for me to fill. If you guys didn't work before with Unity, I suggest you guys can take a look at other videos that you're gonna find on my blog. So in here we have our service API, our region, our terminal, that is this game object. We have the connection light, and we have the output text as text. We also have buttons that in this case we are going to only need one, because I'm going just to enable the microphone for our application to listen to us. So we need to set information in this control. So I'm going to assign terminal to this one. Basically what it's going to do is going to help us with the panel and have control over it. Then I'm going to set the connection light. As I said, it's going to throw if there are any problems. We have the output text that is going to display the result of the service to us. And we have the microphone that is going to tell our application when to start listening to us and when to stop. Let's see the code. Okay, so we assigned a button to this list, and we assign information to these fields, except for key and region that are still empty. What we are going to do in here, we are going to control which one of the buttons is active. Right now the microphone is the only one active. We are going to see the other ones in a moment. And we are going also to set in the output text, once our button is clicked, that we are waiting, our application is waiting for the user to say something. Then the other important function that we have here is that we are going to receive from outside this class information that we are going to set to our output text. Okay, so now we need to assign the class that is going to manage the speech service. That class is this one, that is called Speech Recognizer. As you can see, it doesn't wait for any parameters. So, but I have it open in here to explain to you guys what this class does. Basically, we are going to say our application that we're going to be talking to the application in English, first of all. Then we also are going to set if I have permission to use the microphone, it means that our user clicked on the microphone. We are also going to call to the create speech recognizer. In this speech recognizer, what we are going to do, we are going to create the speech configuration with the language, and we are going to call the recognize handler. In this case, we are going to get the result, and we are going to be displaying that result through our update lunar context that we assigned in here. So that's it. We have everything ready. So basically what we're going to do is we are going to now set an API key and a region for us to start working with our panel. Okay, now I already assigned it, and let's test it. So our application is going to run, it's going to check if the buttons are enabled or not. It's not listening to us. That's important to understand. And what I'm going to do now is going to click the microphone for the application to start listening to me. And once I click it, what I speak to my application is going to be sent to the speech service. Let's test it out. Okay, you're listening to me. Awesome. Okay, as you guys saw, it's already recognizing the language that we are going to use. But in the scenario that we saw with the hologram earlier, the thing was that not only she wanted the hologram to speak, but she wanted the hologram to speak in another language. So let's translate to another language. So we have for that another class that is called Latent Recognizer. So I have a couple of languages already set in here. Let's take a look at the code. Okay, so we have in here our class that is going to manage the translation. In here I'm going to also set the from language from English to the ones that I'm going to set in the UI. What's important in here? Right now I only have enabled to translate to Russian, to German, and to Chinese, okay? And the other thing that I wanted you guys to remember is that when we created the console demo to start our translation earlier, we needed to assign the language that we wanted to translate to. So in here I'm doing the same. So I'm calling the Create Translation Recognizer when my button is clicked. And with the information from the subscription, I'm going to set the from language, I'm going to add the target language, and I'm going to create all the translation, and I'm going again to assign it to the output text as we had earlier. So let's test it out. One important thing before testing it out is to check on the translator button. So right now I only have visible the microphone, but I also need to have the translator button, which is the second one. Let's test it out. We are testing translator. Okay, so we have it in Russian in here. Okay. And that's not something we can test, okay? I'm going to add the option to translate that to Spanish. Let's just say that Spanish is going to be better. And for that, I need to let our option Spanish is added in here. And we are also going to need to be added as a case in here. There we have. So I'm going to translate it to Spanish. Let's test it out. We are testing the translator. Okay. And one of the other important things is what's happening if I want to, I don't know, my customers are in Argentina and I want to translate it to a different language. So can my translator listen to me in other languages? Vamos a trabajar. Nice. Yesterday someone said to me that to understand the potential for cognitive services, we only need to have imagination. Thanks for watching this video. Now I want to finish with what I can say the future holds. Of course, if you have imagination. Let's say we can create holograms. We can help them see us, hear us, talk to us, no matter where you are or which language you are speaking. But with artificial intelligence plus neural networks, we can create even more powerful things. For you to understand what I am trying to say, please check the following video.
So Baby X is a lifelike simulation of a toddler. Hey, are you excited to be here? She's actually seeing me through the web camera. She's listening through the microphone. Ooh, yeah. Baby X is about exploring the nature of how would we build a digital consciousness if it's possible. We don't know if it's possible, but we're chipping away at that problem. Hey, baby, hey.
Problem is an understatement for what Mark's chipping away at. His vision of the future is one where human and machine cooperate, and the best way to achieve that, he thinks, is to make AI as lifelike as possible.
So these are all driven by neural networks.
A neural network is a virtual, much simpler version of the human brain. And the brain is the most complex system in our body. It's got 85 billion neurons, each of which fire nonstop, receiving, processing, and sending information. Baby X's brain is nowhere near as complex, but that's the goal. Instead of neurons, it's got nodes. The more the nodes are exposed to, the more they learn bound.
Thank you for granting access to your microphone. It's good to hear you.
Today, most avatars are basically glorified customer service reps.
Rest assured your health is my primary concern.
They can answer simple questions and give scripted responses.
I love helping our customers, so I'm keen to keep learning.
Yeah, that's perfect. Okay, go. So we have to capture all the textures of their face, the geometry of their face, big gnashy teeth, how their face deforms with all the different facial expressions. How about a kiss? You could do...
With my eyes closed? Because I don't kiss with my eyes open.
Able to synthesize the sort of feel that you're interacting with Will. So Tia, I've got some stuff to hear.
We've got 16 variations.
16 variations. We take the voice data that we've got and then we can enable the digital version of Will to say all kinds of different things.
Here's the forecast. Yo, check out the forecast. Yo, check out the weather and shit. Here's the weather. Check out the weather. Yeah, about to make it rain.
Poke out your tongue.
Tell me about growing up in Los Angeles.
I was born and raised in Boyle Heights, which is west of East Los Angeles, which is east of Hollywood, just east of downtown. Should it sound exactly like me? Nope. Should it sound a bit robotic? Yes. It should. For my mom.